Hello students, today I will discuss quantum free electron theory. So the quantum free electron theory was proposed by Sommerfeld in 1928. It overcomes many of the drawbacks of classical free electron theory. And Sommerfeld explained the classic quantum free electron theory by choosing Fermi-Dirac statistics instead of Maxwell-Boltzmann statistics. He developed this theory by applying the principles of quantum mechanics. So, what are the assumptions of quantum free electron theory? This theory is just like a particle trapped is in 1D potential well. That means the valence electrons move freely in a constant potential within the boundaries of metal and is prevented from escaping the metal at the boundaries because it has infinite potential at the boundaries. Hence, the electron is trapped in this potential well. The distribution of electrons in various allowed energy levels occurs as per Pauli's exclusion principle, and the attraction between the free electrons and lattice ions, the attraction between the free electrons and lattice ions and the repulsion between the electrons themselves are ignored in this quantum free electron theory. And the distribution of energy among the free electrons is according to the Fermi-Dirac statistics because they are fermions, the electrons are fermions. The electrons are freely moving in a uniform potential but prevented them from escaping the crystal by very high potential barriers at the surfaces. The energy values of the free electrons are quantized, and to find out the possible energy values of electron, we can use Schrödinger time independent wave equation, and this problem is very similar to that of particle present in a potential box, and the corresponding energy of the electron is En is equal to n square h square by 8 ml square, where n is equal to 1, 2, 3, etc. Now from the de Broglie matter wave equation, we can also find out the energy of the free electron. So how is that? So all of you know that the de Broglie wavelength, that is lambda, is equal to h by p. H is the Planck constant, and wave vector k is equal to 2 pi by lambda. Lambda is the wavelength. So we can find out that the momentum p is equal to h cut k, and all of you know that the energy is equal to p square by 2m. So E is equal to h cut square by 2m, and the wave vector k is equal to n pi by l. So using 1D potential well, all of you know that sine kl is equal to sine n pi. So k is equal to n pi by l. L is the direct lattice vector and k is the reciprocal lattice vector or wave vector. So putting the value of k in the equation, that is E is equal to h cut square k square by 2m, E is equal to h cut square n square pi square by 2 ml square, and h cut is equal to h by 2 pi. So E is equal to h square n square by 8 ml square. Now what are the merits or advantages of quantum free electron theory? So using this theory, we can explain the electrical and thermal conductivity of metals, thermionic phenomenon. It can explain temperature dependence of conductivity of metals, the specific heat of metals, magnetic susceptibility of metals, and it can explain the quantum phenomenon like photoelectric effect, Compton effect, and black body radiation, etc. And it gives the correct mathematical expression for the thermal conductivity of the metals. So using quantum free electron theory, we can also find out the electrical conductivity sigma expression. So first, all of you know that when an electric field E is applied, the electric field pushes back the electron with a force that is minus small e into capital E. E is the charge of the electron and capital E is the electric field. And we know that the force is also the rate of change of momentum, that is dp dt. So minus E into capital E is equal to dpdt, and all of you know that the P is equal to h cut k, so dpdt is equal to h cut dk dt, and we can substitute equation 2 in equation 1. So dk is equal to minus E into capital E at by h cut. So origin of k space, that means reciprocal space, moves through a distance dk in time dt, and the displacement in average collision t is, that is tau, mean relaxation time. So del k is equal to minus small e into capital E tau by h cut. And all of you know that the momentum p is equal to m into v. So m into del v is equal to h cut del k. So another expression of del k is equal to m into del v by h cut. So we can equate the del k is equal to minus e small e capital E tau by h cut with m del v by h cut. So equating these two equations, we can find out that the del v, that is grid velocity, equal to minus small e capital E into capital E tau by m, and the volume current density J is equal to minus n e delta v, del v is equal to grid velocity. So substituting the del v in the above equation, we find out that the J is equal to n square tau e by m. So we know J is equal to sigma e, so comparing these two equations, sigma is equal to n square tau by m. Now what are the demerits of quantum free electron theory? It is unable to explain the metallic properties exhibited by only certain crystals, because in this quantum free electron theory we have assumed that the electrons in a constant potential field, electrons can feel constant potential field, but in reality there are some band like energy band like structure. So that is why using this theory we can't explain the metallic properties exhibited by only certain crystals, and it is unable to explain why the atomic arrays in metallic crystals should prefer certain structures only. And this theory fails to distinguish between metal, semiconductor and insulator, and it also fails to explain the positive value of Hall coefficient in the Hall effect experiment. Now in the statistical mechanics, all of you know that there is a Fermi-Dirac distribution function, that the fermions, the quantum particle fermions obey the Fermi-Dirac distribution function, and this is the expression of Fermi-Dirac statistics. So what is Fermi level and Fermi energy? As we know that for a metal containing n atoms, there will be n number of energy levels in each band, and according to Pauli's exclusion principle, each energy level can accommodate maximum 2 electrons. One is spin up and another is spin down. So at absolute zero temperature, 2 electrons with opposite spins will occupy the lowest available energy level. The next 2 electrons will opposite spin will occupy the next energy level, and so on. Thus, the topmost energy level occupied by electrons at absolute zero temperature is called Fermi energy level. That means the highest occupied energy level by the fermions. This is called Fermi energy level, and the energy level is referred to as Fermi level. The energy corresponding to that energy level is called Fermi energy. Now we will introduce two terms, that is Fermi velocity and Fermi temperature. This is mainly important for mathematical calculations or numericals. So velocity associated with the Fermi energy is called Fermi velocity, that means velocity of electrons occupying Fermi level. So for an example, for sodium, the Fermi energy is around 3.2 eV. So all of you know that the half mv f square is equal to ef. So putting this value, we can find out the Fermi velocity is equal to 1.1 into 6 meter per second. And the Fermi temperature, this is the temperature associated with Fermi energy. So kBTF is equal to EF. Kb is the Boltzmann constant, TF is the Fermi temperature. So if you know the Fermi energy, you can easily find out the Fermi temperature. So that's all the quantum free electron theory.